Hello everyone, this is Dennis with another tutorial about photorealistic leaf material creation in Substance Designer using photogrammetry pictures. So the photometric stereo scanning method that I mentioned in another video. And so someone reached out to me and asked how to do this in specific. I've shown it already in a workshop I did for Beyond Extend, but apparently the node system wasn't quite visible and the resolution wasn't that high. So we're gonna take a deep dive into that graph, like picking out every single node. So if we minimize this. So this is the graph that I've used during that video, and I will go slowly through every single node and will show the settings, so you can ideally one-to-one recreate this, and you can just input your own photos, and in the end you will get a photorealistic material. So in order to understand this workflow, I want to give a little overview again, sort of like quoting the video. The workshop I did for Beyond Extend. You can find that one on YouTube as well. It's a 2-hour workshop that explains everything about foliage creation for video games. And in there, you will find a section that is called Leaf Atlas Creation using Photogrammetry. And the thing here is that in that section, I show my equipment, which might be useful before you get started. If we skip further through, these are the actual leaves that I've taken a picture of before I started working. And this is my setup. So you would basically put your leaves on a screen with that is backlit, so you get your subsurface scattering map. You can turn that screen off and on. I used my iPad, and you need a tripod with a pointing down camera to make your scans. And then this, I guess, is the most important slide in that presentation, where I explain how this is done. So you basically have one light source and you rotate it around your setup, and while your entire setup is immovable, you will just take pictures while moving your light source around, and in the end you will end up with a set of pictures that can then be used in Substance Designer. The full workflow is all explained in here. I'm just gonna keep it short and precise. You can rewatch this video if you like it. You can find it on YouTube. So, and you can see here you can see here that this is the exact graph setup that we are currently having open in Substance Designer right here. So the guy who reached out to me sent some pictures over. So I will first show the method using my own leaves, and I will then go and we take a look at the specific case from the leaf data set that was sent over to me. So I want to mention right away, like without using these leaves. So I got 3 data sets. One leaf data set shows a leaf scan from all different, like with different light source angles, which is the back of the leaves. And we got another full scan set, which is the front of the leaf, and here with specular values, and then this one using a sort of like likely cross-polarized setup where the specular is already missing. A little bit of background information on that, and I really like that this sort of like chrome sphere is included because now we can nicely see where the light is being placed. This will be handy later on for when we want to identify which direction the light is coming from. So in Substance Designer we can pick the correct node and stuff like that. So in general, the main difference between the specular set and the cross-polarized set is that with cross-polarized pictures, you generally get a better base color representation, which means that your Substance Designer nodes and stuff, they don't have to make the work to cancel your direct lighting or your specular information to cancel that one out. So as that is already gone, you will end up with a much flatter and realistic looking base color. However, sometimes the normal map isn't that strong, because obviously what really helps here with the normal map definition is that you have the bright and shadowy areas, which then help with the definition of the normal map. That is something we do not have in here. So for this video, I'll be using the specular set, and that will give us a nice normal map, while this one will give us a better base color map. And in combination, that technique can be even more powerful. Like ideally, you would create the base color using a set like this, and maybe only the normal map you will create using a set like this. All right, so let's get us started. So what we can see here, I'll pretend that people watching this video are not knowing much about Substance Designer, because like when you're doing general photogrammetry and stuff, I do not expect people to have much in-depth knowledge about Substance Designer. So we're going to cover everything. So in general, in Substance Designer, before you get started, you just want to pick a preset. So you would just go to File and say New Substance Graph, and it will come up with a set of graphs you can pick from. So like usually you get options like metal roughness and stuff. Obviously, we do not need metal maps and things like that, so we don't really need that. You can also start just from scratch. I will show you how to start from scratch as well, because there is no such foliage setup or anything like that. So to cover all grounds, I will just show you how to start from scratch as well. So when you start from scratch, that means you wouldn't have any of these nodes. There will be nothing. And the first question is, how do you create your outputs? Because what you want in the end is a base color. You want to have a normal map, a roughness. You don't need a metallic map. You want to have a opacity. I should actually rename this to opacity. An ambient occlusion. You maybe want to have a height map as well, but not necessarily, and a subsurface scattering map. So that is quite important. And how do you create these? So what you would do is you press spacebar and you type in output, which will create an output node. Right now, there is no data defined for it, so we'll need to define some data. That can be done in here. The usage is currently unclear, so we add an item, and we can, for instance, say we want this to be base color or normal. So if we pick normal, then this output knows that it is expecting a normal map. And the color space, we do raw, I guess. If you pick nothing, that is raw. So this one also doesn't have a color space, and you can already see that this is set up correctly. And then you might want to rename this identifier to normal, and that is your normal map that will be exported. And you can do that with a base color. As you can see, for the base color, this usage is set to base color. For the roughness, it is set to roughness, and so on and so forth. Opacity, ambient occlusion, subsurface scattering is just called scattering in Substance Designer, and height is height, and metalness you don't need. So this is how you create your outputs. And now your inputs. So what you need is a set of leaves, a set of pictures, and this is what we are having here. So this guy sent me these pictures, and as you can see, we've got this metallic map. And what is important for this technique is that you take your pictures in consecutive order. So you need to have a static setup, and you rotate your light source around your setup. As we can see here, the light source is in the bottom right corner. The next picture is then top left, and so on and so forth. The light source is being rotated around this object, and that is important, and that needs to be in order. So for the leaves that I have in here, and you can see that, so we're gonna click through every single leaf. So by the way, you can add your leaves by clicking on these resources, or just clicking on here, and you say add or import. Basically, if you import something, it will be imported into your Substance Designer file directly, but I tend to just link things so you can easily update your pictures, or the file size is not that big as well because you're just linking the resources. So you would link your bitmap to this, and then a resource folder will be created, and as soon as the resource folder is created, you can from here you can say link bitmap, and then you can pick whatever pictures you like, and they will be added to your scene. And once they are in here, you can easily drag them in, and a bitmap node is being created out of them. So now we have a bitmap node, and you can see the lighting here is coming from the bottom left. In the next one, it's coming from left. In the next one, it's coming from top. Then we have top right, and then we have right bottom sort of, and then we have bottom. So it is going clockwise. I changed my lighting clockwise. It is changing clockwise. This is important for these nodes. I will get to in a bit. So obviously, Substance Designer works with standardized texture sizes, which means that your pictures will be stretched, or might be stretched into like an 8K to 4K resolution thing. Well, if you haven't taken an 8K times a 4K resolution picture, your things appear to be stretched, or could be. So in most cases, you will need a transform node to make this fit into a standard 4K by 4K texture or whatever, or you basically need to stretch your leaves back to what they need to be. And then once you've done this for one bitmap, you can copy over the same transform node and apply this to all your leaves. Maybe we should take a look at the final result, because I'm going to replace these nodes with the other leaves very soon. So we can see that this is a full material featuring roughness as well. The normal map is in place too. And obviously your pictures, they will not give you everything. Your pictures will only give you a base color and a normal map. The roughness and all the other sort of like details that you want to have in your texture, they need to be created manually. And this is what I've done here, and I will go over it. All right. So I would say before I cover all the rest of the nodes, we will import the other leaves and make sure we get those in as a sort of like test case. All right, so what I will do now is I will link and I'll select the leaves that we are looking for, plus the alpha, and I'll add them to my scene. Now, as these pictures are 6K pictures, this might take a while, and I hope my program doesn't crash. I will put the recording on pause and unpause once they are imported. Oh, there they are. That was quicker than expected. All right. The guy who sent over the pictures was kind enough to attach the angles. So we can see this is 0 angle rotation, this is 45, 90, 135, and so on. That makes it easier for us because we already know which angles they will be in. So this might take a while now. As we drag the pictures in, they need to be rendered, and rendering sort of like 6K pictures might take a while. There they are. And as you can see already, they are distorted. So we need to fix that by using a transform node. We'll create a transform node. And I'm gonna change the width to the height to 4K. And now we sort of like stretch it back by 50%. So we can actually make this precise and go into the width and do like 50%. Oh, it seems to be, that is a little bit tricky. It seems to be, it needs to be 75 because it applies it on both sides. So this will give us the actual, yeah, this appears to be round enough for us. So we set this to absolute and we turn off tiling, so we get rid of all the rest. Now we copy this and paste it around. All right, and we link all the other pictures to it as well. Okay, now we do a quick double check whether everything is rotation wise in the correct order. Light at the bottom, then it goes to bottom right, right, top, yeah, top, top left, and bottom left. And this is everything we need. And then we need the translucent map as well. We apply the same transform to that too. And that fixes it. What we then have to do is we'll create additional inputs for the multi-angle to albedo and multi-angle to normal inputs here. So we will change the sample count from 6 to 8. Which will create 2 additional inputs. I will be deleting these now. That will already save a lot of performance. And then the multi-angle to normal, we also change the sample count to 8. And now we can start inputting our pictures. So one after another. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So this seems to be working. So we can see a nice and flat delighted base color, which is great. And now we need to do the same for the normal map. So we plug all of those in here. Four, 5, 6, 7, and 8. However, we will see that the normal map is sort of like inverted right now because the angle is set to clockwise while we are actually doing a counterclockwise thing. So this is currently not looking correct because we haven't hooked up our translucent map yet. So we'll be feeding that one in. Let me do this really quickly. Plugging that in. That already helps. So now we already see a really nice textured, highly detailed leaf, which is pretty good. But we need to do a few more things to make this look correct. To make this look correct, I need to adjust this banding, because that is something I've done for my previous picture, which is not needed anymore. And we do want to change this shape here and want to make sure that it is cutting out this sort of like iPad, this black area from the screen. So now that is being cut out nicely. One last thing, we want to make sure that we get rid of the metal sphere. So what I would like to do is picking a gradient radial. We'll just threshold it So we can move it around. We can then add a transform. Actually, we don't need a transform for that. So, and we'll just subtract it from our actual opacity map. I do see a few more artifacts like this thing, but I will ignore it for now. You can be more precise and remove it yourself. So we're gonna blend this together with the subtract, and we want to subtract this circle right down there, and reconnect. And now it should be gone. So now we have isolated our leaf, which is great. Yeah. And we got the full material down. So can go full screen to embrace this leaf to its full extent. We can see every single cell on that leaf. The normal map is working nicely. The roughness map is doing a good job. Yeah, so this is looking decent. Okay, now let's take us a look at the different nodes that I've used to make this material look correct. I believe I need to do some stuff in here. I don't entirely know what I did here. I think this was just to fix up some issues with my other texture. So this, I think, isn't needed anymore, if I want to be perfectly honest. So let's rewire that. Yes, and that is fixing up some artifacts for us. So our base color is looking nice and clean. All right, so I do want to mention a small issue that you should take care of before making your scans. Like you want to make sure that you do not have that much dust on your display area. Why that is because obviously you are using the surface scattering map as your mask for your alpha. And if you have dust particles that are a little bit too big, like this little thing there, or these, and that is creating artifacts in your opacity map in the end, which is why if we take a look at the opacity, we are having these little things going on here, right? And obviously you don't want that in your opacity map. There is a method to get rid of those as well by using a little hack that I like to use quite often whenever I have these artifacts. So what you can do is you can turn this into a flood fill, and you can see how these are sort of like much more colorful than this one. This is because of the size, and you can do a flood fill to B-box size, which will pick out everything that is smaller than a certain threshold. And now you can see they disappear. They are now gone. And you would now use a threshold node to make your leaf full white again, because this is not white, this is gray, this is full white. And yeah, your artifacts are pretty much gone apart from this. But as you can see, there is there are no artifacts like that anymore. And that is what you can use as your opacity map. And this way you remove what's left there. Like you can see these little artifacts right there. So we don't want those. That's an easy fix. Okay, now let us finally take a look at all these nodes. So I go over this again really quickly. You need your pictures. They all need to be in the correct. They all need to be in the correct order. Next step, you use the multi-angle to albedo. You plug in all your pictures. You make sure that your sample count is matching the count of your pictures. You use the multi-angle to normal node. You make sure that your sample counts is matching the count of pictures. You set the normal map format to DirectX if you want to use Unreal Engine or any other software that is using DirectX, or OpenGL if you need your OpenGL pipeline. The intensity controls the intensity of the normal map. If you decrease the intensity, your normal map will become less strong. You can further increase the intensity of the normal map by using a normal intensity node, which I did here, which will pushes the normal map intensity a little further. In the multi-angle to normal, you can define the first sample light angle, which might be incorrect here as well. So let us double check that. So the first input light angle is at the bottom center. So we should make sure that in the multi-angle to normal, this is placed at the bottom center, because that is what your first light is coming where your first light is coming from, and that is calibrating a normal map. And you can see this is looking much more realistic than it used to look like when it was here, right? So it needs to be here actually, and only this will give you the most accurate normal map. If you don't do that, your normal map will become incorrect according to the lighting angle. So that needs to be matching. And again, we need to set this to counterclockwise, because our lighting in our example here, our lighting is being rotated counterclockwise. Okay. Next, the base color. The base color is the shortest track of all of them. After the multi-angle to normal, we already have a decent base color, but sometimes you want to apply some tweaks. In my case, I added a sharpen node. A sharpen node that can be shown here just makes sure that your pictures stay nice and sharp. Don't overdo this effect. Keep it subtle. I put it to 1.12 in here. And that is being used in the base color output. Next, your normal map. Your multi-angle to normal map is then being fed into a normal intensity node, which I mentioned before. This can further increase or decrease the normal intensity of your leaf. This was just an experiment and is not needed, and that is directly fed into the normal export. The next map then is the roughness. The roughness is the most complex thing because you need to set it up yourself. You could just use the base color and create a grayscale conversion. By doing that, you would end up with this. This can be used as a roughness map, but I found that this is not creating the most realistic results because it is technically incorrect. So what I did is I used the multi-angle to albedo. I indeed did a grayscale conversion as a start. And what I did afterwards is I blended in my subsurface scattering node. So here we have the bitmap for the subsurface scattering. And I did a grayscale conversion on that one as well. I did a histogram scan. This is to push the contrast to absolute maximum. So we basically create a black and white mask. And that I used as opacity in a blend where I blend it itself with the roughness. And that pushes the tops of the cells a little in roughness. So you get a slightly more shiny look on the cells themselves. So this is what it was like before, and this is what it looks like by pushing the roughness of the cells, and that can look quite nice. What I did then is I did a histogram range that is changing the range of your black and white image. So you can basically move your values closer to the white or closer to the black. In that case, that is a nice global control to make your leaf appear more dry or more wet. So if I were to change the position of this, as it becomes darker, your leaf becomes more wet. So this looks like now, as it is a very young leaf or right after some rain or stuff like that, and you should definitely not overdo that. And the further you drag it towards the bright, the more dull sort of like it becomes. And I found out that a value of 0.6 is a good specular value for a standard stuff like leaf, but always take a look at your reference and make it look as best as you can to what you can see. Next, I blend in some higher roughness values for the decayed areas, because obviously what we also should take into account are these brown bits. So as those are usually drier than the rest of the leaf, I wanted to make sure I take them into account. So as you can see, I give them a brighter value by using this as a mask, and that is coming again from the subsurface scattering. This is ideal because these are the darkest areas on our leaf, so we can easily mask out the darkest areas by using a color to mask. And here we change the color in a way that we sort of like, with this range, you can pick a color and it will turn it into a mask. So everything that has this color will become white, and everything that does not have this color will become black. And the range and the softness will then define how far can values go away from the defined color and still be included into your mask or not. So I went with this setup. I then blurred it slightly so we get a little bit more of a fuzzy edge. And then I used the levels to push the blur. So we sort of like expand that area slightly. And then I blur it again. But I believe, this is currently set to 0. So I actually don't blur anything here. And that is then being used in here to push the roughness of the dry areas. And that is then creating the roughness map. Next, we have the metallic. Metallic is absolutely not needed, so we can also delete that from the project. The opacity map is created as following, because we only have the subsurface scattering map for that. We need to apply some sort of like hacky methods potentially in order to get a clean opacity map. So again, we start here with our bitmap. We start with our subsurface scattering map. We then go, it is in here. And I blend it with full white. So I do this to get rid of the black banding, because it needs to be white, because I intend to invert it in the end. Next, I do a grayscale conversion. So you can already see that the leaf is much darker and everything else is bright. But we still have quite a few artifacts here that we need to get rid of. So what I did next is I created a shape. And you can control the size with like these bends. And that is what I did to get rid of anything that is an artifact at the top and at the bottom, which in this example, we don't have anything, which is why it was fairly easy for me to just turn it off. And in the next blend, I create again a shape like this, and I transform it, and I sort of make sure that I get rid of that. I could also get rid of that in a very similar way, just making the same on the left, basically. I think we have something like that here actually. So I do another blend. Yes, and I could just drag this over. And as you can see, it is disappearing now. Stretching it. And stretching it, you can see that gray thing is now disappearing. So because this is also masking any artifacts, masking these artifacts out. Boop, they are gone now. Then we do a histogram scan, so we get a full black and white image. Next, we invert it because we obviously want that our leaf is white and the rest is black. And then this is my little thing that I did a couple minutes ago. I added a radial gradient, I used a threshold, and that way I get rid of the chrome sphere in the corner. And then I use the flat fill technique, flat fill to B-box size, to get rid of these little artifacts that you would find outside of the leaf caused by dust on your screen. So in that way we get a pretty clean leaf opacity. Next, we have the ambient occlusion. The ambient occlusion should be just kept very subtle, because on a leaf you do not get much ambient occlusion unless it's curled heavily or anything like that. So what we do with the ambient occlusion, we use again the subsurface scattering map. We reuse the grayscale conversion and we apply a few modifications. First, I use a histogram scan to increase the contrast. Then I invert this because I want to have the ambient occlusion to appear in obviously only between the cells and stuff. So I invert it. I use a slope blur grayscale, which is creating this. This I did in specific to get rid of any ambient occlusion on the edges of the leaf, because that can sometimes cause artifacts. And then I blur it, and then I use a curve, and that curve is making sure that the ambient occlusion is not getting too dark. So I curve it so it's getting a little bit brighter. We can always adjust this curve to control the ambient occlusion, but this is what I went with for the ambient occlusion. You can also invert this. I mean, you could also argue that as the veins are pointing out, and the cells actually point inwards, we might want to invert actually this map. And then we need to make sure that our curve is being adjusted though, to lower the ambient occlusion significantly. So basically like this. And in the ambient occlusion, like here, we would do a histogram range. And that way we can make the ambient occlusion brighter. So this would be no ambient occlusion. And the further you pull it down, the more ambient occlusion you get. So I would keep it quite subtle and not overdo it. Right. The height is currently empty. Again, you could add your height map that can be created out of your normal map. So you can make height to normal or normal to height, I believe. Normal to height. And this would give us a height map. You can then also tweak that. Low frequencies, mid frequencies. Like that. And that way you would get a height map as well. And now you have additional support for your normal map also in your height map. And that's everything. And the subsurface scattering, just goes straight into the subsurface scattering. All right. That summarizes everything. And what you can do now, you just press, you just go to your graph, right click, export outputs. You go to the folder where you want to save your textures. You leave everything checked. You would press export outputs right there. And what you will get is something like this. 1 second. Right. So this is what will be outputted. So you will get a base color texture, then your subsurface scattering, your ambient occlusion, then height. That was an older export where I didn't have any height. Your normal map is right there. Your roughness map is here, and your opacity map is there. And this you can make a photorealistic material out of, like you can see here in Substance Designer in the viewport. And that concludes the entire video. I know it was a fairly long one, but people requested a full breakdown of this method, and I hope that now everyone can create their own photorealistic leaf material using photoscans. And again, if you want to take another look at how this method works in specific, like how you take the photos and everything, please watch this video, the Mastering Foliage Art for Games pipeline breakdown with live demos. It's a Beyond Extend workshop I did. It is available on YouTube. You will easily find it. And there is this section. It starts at 1 hour and 2 minutes, where I explain the photogrammetry method. I'll show my setup, the hardware I use, the explanation of the workflow right there, and how to set the graph up roughly in Substance Designer. And yeah, that should be it. I hope that was helpful. Please let me know in the comments, and thank you so much for watching. Until next time.